Okay, now the fourth question of this June 2020 paper 4-2. It's a small smooth spheres A and B. When it says small, the word small when it is used, so this means that we have to ignore the size of the object. Okay, so small smooth spheres A and B of equal radii of masses 4 kg and 2 kg respectively lie on a smooth horizontal plane. Now the spheres are smooth and the plane is smooth. So that means the objects can really move with a constant speed there. Okay. So it says initially B is at rest and A is moving towards B with speed 10 meter per second. So if this is your B here, okay, and this one is A over here, okay, and its speed is 0 meter per second, and this is moving towards A, this is 10 meter per second, this is moving towards A, okay. Its mass is 4 kg. This is 4 kg and this one is 2 kg. It says after the spheres collide, A continues to move in the same direction but with half the speed of B. So we have the rule here. The first formula that you need to remember that the momentum's formula is that is mass into the velocity. This is the first formula. There are two formulas that you guys need to remember. Second formula is that is basically the law of conservation of momentum, that the momentum before the collision is equal to the momentum after the collision. Okay, so now when they have collided, this is what is before that collision. Okay, and then after that collision, what is happening? It says a continues to move in the same direction, okay, but with half the speed of V. So it means this is A going in the same direction. This is B. Now this B, suppose if this is going at a speed of 2V meters per second, then A's speed would be V meters per second. Okay, so this is 4 kg, this one is 2 kg. Okay, so um, so we have the formula that momentum before the collision, that is going to be 10 times 4. Okay, we have 10 times 4 plus 0 times 2, that is equal, the formula is basically m1 u1 plus m2 u2, that is equal to m1 v1 plus m2 v2. Okay, so this is 10 into 4 plus 0 into 2, that is going to be v into 4 plus 2v into 2. So you have 40, that is equal to 4. This is 8v, Hannah. So this v is going to be 5 meter per second. So that means he was asking for the speed of B after that collision. So the speed of B is going to be 10 meter per second. After that collision, V is going to move with the speed of 10 meter per second. Let me keep on checking the answers with this. Come on, yeah. Okay, I believe the answer would be correct because there's some problem with that. Let me resolve that problem. We have this answer. Achieve this answer. This is VB, which is 10 meter per second. Acha bacho. Then it says, let me scroll this up. It says a third small smooth sphere C. Okay, a third small smooth sphere C of mass 1 kg and with the same radius as A and B is at rest on the plane. B now collides directly with C. Okay, now remember at what speed B is moving right now. Okay, so let me change my. By the way, you keep these things noted. Okay, because I'll be needing this information from you people. Now, suppose, let me change all this. Okay. Okay. So, yes. So let me change this. Let me change this. Okay. So we are ready. Uh, okay, guys. It says now we know that B is moving at a speed of 10 meter per second, है ना? And C is at rest. Its mass is 1 kg. Its mass is 2 kg. Okay. So it says after this collision, B continues to move in the same direction, but with 1/3 of the speed of C. So let me assume that this speed is going to be 3v now. So the speed of B would be just V. It's easier to write 1/3 of 3V. So that is why I'm supposing that this is 3V over here, okay? And this is your C over here. This is 1 kg. This is 2 kg. Show that there is another collision between A and B. Now, to prove that there is another collision between A and B, remember what is the speed of A right now? 5, okay. So just keep that in your mind that A is moving at a speed of 5 meter per second. How can a third collision be possible? Exactly. So if VA is greater than VB after this third collision, then it means that they are going to collide for the third time. Okay, so let's find what happens after this third collision. Okay, so before the collision, you have 2 into 10 plus 1 into 0. And then after the collision, you have 2 into V plus 1 into 3V. This gives us 20, and that is going to be 5V, Anna. So this V is going to be 4 meter per second. So that means velocity of B is 4 meter per second. So this is moving slower and A is following that faster, okay? So since your velocity of A is more than the velocity of B, so this means there is going to be a third collision. Okay? Okay, now let's move on to if there is another part here. Yeah, there's a C part. It says A and B coalesce, that they become one, like, they get together, okay? They do not depart, they are one body now, okay? So they coalesce, and during this collision, find the total loss of the kinetic energy in the system due to the three collisions. Okay, so we have, let me just make some space here, okay? And please remember all these velocities, okay? Okay, I'm going to use these diagrams here. Okay, and this. Okay, so this before and after will also be used here. This is your C here. This is your B, and this is your A. Now, in the very beginning, this A was moving with what speed? 10? 10. Okay, this was moving with 10 meter per second. Its mass is 4. Here the mass is 2. And this C was also at rest. Okay, this is 1 kg. And this is after the third collision. Okay, after the third collision. So this B and C, they have coalesced. Okay, Anna, I see Anna. Okay. Just 1 minute. Um, A and B coalesce. Okay, let me erase this. So A and B, they have coalesced here. So let's find what is their speed when they have coalesced. Okay, so I need to do that. Okay, before that, velocity of A is 5 and the velocity of B is 4. है ना? So that means 4 into 5 plus 2 into 4. That is what, this is your A situation and this is your B's situation. The momentum of A and the momentum of B. And now they have coalesced. So they have a total mass of 6 kg. And we assume that their speed is V. Okay, this is 28 and this is 6V. So they have a collective speed of 28 over 6, that is 14 over 3 meter per second. And if you want to find the loss of kinetic energy, you should have the kinetic energy right now before any of the collisions, okay? So you just add up all the kinetic energies of these three particles which are moving or which are not moving here, okay? So that is called the total kinetic energy of the system, okay? So before the situation, the total kinetic energy that we have, that is going to be half into m into v, that is 10 squared, and that is going to be 200 joules, okay? And after all these three collisions, what do we have with us? The total kinetic energy of the system is going to be, now this is a block of mass 6 kg and it is moving at a speed of this, okay? This is half into 6 into 14 over 3 whole square. And then this c is also moving. What is the speed of c? Was it 12? That is 12. Okay. So that is going to be half into 1 into 12 whole square. Now please use your calculators and tell me what is this and keep it in exact form. Yes, please use that calculator quickly. So we have this is the this many joules after the third collision. That is the kinetic energy of the whole system, and we are required to tell that what is the loss in kinetic energy. So that has to be 200 minus. Please use your calculators again and tell me what is this. Yes. Huh? This is 188 over 3 joules. Let me check the answer. Uh, 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 where is the, yeah, this is 188 over 3 joules. So that is the loss in the kinetic energy. Here is the answer, okay? This is the answer that we have obtained. 188 over 3 joules. Okay, so that is the end of this question here. I hope there is no question. Okay. So this is an easier topic added to your syllabus. That is the momentum. Okay? Okay, I hope you find this easier. Okay, so here is question number 5. Okay? You try this and then I'll be doing it. Okay, guys, a car of mass 1250 kg is moving on a straight road. Now, this straight road does not mean that this is horizontal or inclined. Okay, you have to read the question carefully. Now, in the A part, it says on a horizontal section. Okay, so this means it's a straight horizontal road for the A part. The car has a constant speed of, you must, like in your mechanics paper, you must pick this constant speed term very carefully. Now, constant speed actually means a state of equilibrium, okay, where the forward forces are equal to the backward forces. Okay, so that is a kind of equilibrium over here. And you have that lovely formula F equal to ma. Okay, this F is basically the resultant of the forces. That is the driving force minus the resisting force. And when the speed is constant, your acceleration is zero. So this ma part becomes zero. So you can say that the driving force is going to be equal to the resisting force. Okay, so we can do that directly. Okay, so there is a constant force of 750 newtons. That is the resisting force, resisting the motion. So we can say that our driving force is also going to be 750 newtons because of that constant speed given to us. Okay? Now it says calculate in kilowatts the power developed by the engine of the car. Now the power's formula is power is going to be F into V. And this F over here, you see this F comes so many times in your mechanics formulas. And you must know that for what formulas, what does this F represent? So in your powers formula, this F is representing the driving force. In F equal to ma, F is representing the resultant of the forces. Okay, so when you have power equal to F into V, so we have to find this power. Okay, so this is going to be power we have to find, we have the forward force that is 750 and we have the speed that is 32. So please tell me how much is this? Okay, this is 24 kilowatt. It says calculate in kilowatts. So you have to write it as 24 kilowatts. You have to see in what form examiner uncle is asking for the answer. Okay? Okay, now let's go on to the second part. It says, given that the power is suddenly decreased by 8 kilowatt. Now, again, there is a big difference in decreased by and decreased to. Right? So the power is decreased by 8 kilowatt. So that means the new power is going to be 16 kilowatt. Right? So now we have the power that is going to be 16 kilowatts. Okay. And let me erase this, all of this. Okay. So now it says that find the instantaneous deceleration of the car. So that means, again, that lovely formula F equal to ma, that is the lifeline of your all of this mechanics, okay? So we have to find the deceleration of the car, okay? So remember, do not assume that the speed is going to change. Focus on this word instantaneous. It means at that instant, your speed is still 32 meter per second. Your backward force, what was that backward force, by the way? 70? Oh, 715. That is 750. Okay, 750. Thank you. 750 newtons. And the forward force is also 750 newtons at that instant. Okay? But the power has changed over here. Okay, so this means we would need to determine that what is this forward force. We know that the speed is 32. This is constant. You will have to determine that new forward force. Okay, and you have the formula power is equal to F into V, and this F would be power over V. Okay, so the forward force, guys, is going to be now 16,000 over 32 minus the backward force, that is 750. And what was the mass? 1250. And you have to find the acceleration here. Okay, so please calculate this. This is minus. Okay. So your answer is going to be 0.2. That is the deceleration, 0.2 meter per second square. Okay, that is the deceleration. Okay, then we go on to the B part. It says on a section of the road inclined, I need to clear all this. Okay. On a section of the road inclined at sine inverse of 0.096. Now, this is really a cunning step taken by the examiner. He is going to confuse you by this, okay? Now, this is an inclined road over here, okay? And if you assume that this is your alpha, please try to minimize the use of calculator here. Don't start finding the sine inverse of 0.096. Can I say sine inverse of 0.096 is going to be that angle alpha? And then sine alpha is going to be 0.096. That is what you will be needing while finding the component of the weight parallel to this surface over here, okay? So here is the car, okay, going up. So the weight over here, that is 12,500, okay? And we need to resolve it like this here, parallel and perpendicular. So this is your alpha here. So guys, this is going to be 12,500 sine alpha. This one is 12,500 cos alpha. You may not need this R over here because you are given the frictional force. Okay. Okay. It says the resistance, the motion of the yeah, this is the resistance force over here. 1000 plus 8V when the speed of the car is v. Okay, so now suppose it is going upward with the speed of v. Okay, then the backward force would be 1000 plus 8v. The car travels up the section of the road at a constant speed with the engine working at 60 kilowatt. Again, we have the constant speed. So this means that all the up, like this is your driving force over here. The driving force is going to equate the downward component of the weight and plus this resisting force. Okay? So we have to find the constant speed. So that's, I think, no problem for you. The forward force, again, power is equal to F into V, and this forward force is going to be power over this V. So the power is 60,000, है ना? So 60,000 over V minus, yeah, Sida we can write equal to these two forces. One is 1000 plus 8V, and the other one is, now you can simply write it as 12,500 times 0.096. Yes? Yes? Am I doing something wrong here? No? Okay. 12,500 times sine alpha, that is 0.096. So if you do that cross multiplication, you will end up with a quadratic equation. So don't be worried with that, okay? Don't start thinking of factorization, okay? So you have, can you please tell me what is 1000 plus all of this product, 12,500 times 0.096? 1000 plus this, what is this? This is the equation that you people get, okay? Now there was a V over here. Where did I just forgot to write this V over here, okay? So we have a quadratic equation here, 8V squared plus 2200V minus 60,000. Okay, minus 60,000. If you see that 8 is common from here, you can just lighten up your equation. This is V squared plus 275V and then 60,000 divided by 8. That is 7,500. Okay. And now you use a quadratic formula and let's see what do we get. Okay, so after using the quadratic formula, you have V equal to 25 meters per second. Please show a step of that quadratic formula being applied, okay?